3.4 Properties of Logarithmic Equations. So we're going to use the properties of logarithmic equations to expand each logarithm expression as much as possible. Alright, so let's try this. So the first one right here, because we have multiple factors that are in the argument, there's multiplication right there, because y to the 6 and z are being multiplied together and those are factors, we can tear this apart into two logs with the same base b being added to each other. So we have log base b y to the 6 plus log base b z. Right? Now next step is we can take this exponent from up above the y and stick it in front. And then what we end up with is 6 log base b y plus log base b z. Alright, so that's the first part. Alright, we can't really expand this anymore. That one's done. The next one, we have a fraction. So we are going to tear this one apart into two different logs, but now instead we are going to be subtracting. So we have log base 6 square root of c minus log base 6 of 36. Now the first one, we need to rewrite this radical as a fractional exponent. So that square root turns into a 1/2 power, and then we can simply pull that to the front. So we end up with 1/2 log base b of c minus, now this one's a little bit different, the log base 6 of 36. So basically it's asking 6 to what power is 36, or another way of writing that would be log base 6. And if you broke this up into factor into 6, that'd be like 6 squared, right? So you just pull it to the front, and then all this would go away. Just another way of saying this is going to be equal to 2, right? So all that would go away, and you'd be left with a 2. Or you could say 6 to what power is 36? 6 to the second power. 6 times 6 is equal to 36. You'd still end up with a 2 either way. Okay, next one. Because this is a fraction, we're going to use the division. So we'll break it apart. Log base 3 of 9 minus log base 3 of square root of x plus 7. Okay, so the first one is saying log base 3 of 9, or 3 to what power is 9? And we would say, oh, that's 2, minus. The other one is log base 3 of square root of x plus 7. So we would keep the log base 3, but we would turn this square root into a fractional exponent. So we would take that square, that half, and pull it all the way to the front. That half would go to the front, like that. So then we end up with 2 minus 1/2 log base 3 of x plus 7. Okay, so we move on to the next one. In this case, we do start with a fraction, so I'd probably break it apart initially with log base b x squared y minus log base b z to the 7th. Okay, so the first one, since we're multiplying these together, we're going to break it apart using multiplication. So that gives me log base b of x squared plus log base b of y minus log base b of z to the 7th. So the last one I can pull that 7 to the front and right in front, and the first one I can pull that 2 to the front, and then I end up with 2 log base b of x plus log base b of y minus 7 log base b of z. All right, moving on to the next one. Now, we do have a fraction, so I'm probably going to start with turning the division or fraction into subtracting logs. So we end up with log base g square root of x times y eighth. The y eighth not underneath the radical sign. And that's minus log base g of z to the sixth. Okay, so I'm going to tear apart the first one because I have multiplication there, so I can break that apart into two logs being added to each other. So I end up with log base g of square root of x. I'm just going to rewrite that as x to the half power plus log base g of y to the 8th power minus log base g z to the 6th power. So all these exponents, the half gets pulled to the front. The 8 of the y exponent gets pulled to the front. We have the 6, which is pulled to the front. Get that right? So we end up with 1/2 log base g x plus 8 log base g y minus 6 log base g z. Okay, the last two on this page. We start with a radical, or it looks like a 7th root, right, of a fraction. But first thing, we're going to turn the radical into a fractional exponent. So we end up with, instead of the 7th root of s to the 8th t over 9, now we have the fraction s to the 8th t over 9 to the 1/7 power. So we're going to bring that 1/7 to the front. So we end up with 7 log base 3 to the s8 t over 9. Okay, and now that we have a fraction here, that's 1/7. Now that we have a fraction here, we're going to break it off with subtraction, two different log subtractions. So we keep the 1/7. Now you can either put it in parentheses, or you could just, since you break this apart, make sure you have everything to the with a 1/7 exponent, or not exponent but coefficient. It's the equivalent, right? So I'm just going to leave it out in front for now. So we end up with log base 3 of s to the 8th t minus log base 3 of 9. Okay, I'm going to try to simplify all this, and then I can distribute the 1/7 later on if I want to. So I'm just going to keep the 1/7. Okay, now this right here has two different factors. Log base 3 of s to the 8th t has two factors being multiplied together, so I'm going to break it apart by adding two different logs with the same base. Log base 3 of s to the 8th plus log base 3 of t minus log base 3 to the 9th. Okay, so now I'm going to try to bring this 8 for the first exponent to the front. Put it to the front. So we end up with 1/7, and that is 8 log base 3 of s plus log base 3 of t. Now the previous one, log base 3 of 9, is basically saying 3 to what power is 9? And I would say, well, 3 to the 2nd power is 9. So we end up with something like this. Now we could theoretically distribute this 1/7 if you wanted to. It's not really going to simplify much, so it's probably acceptable to just leave it like this. But either way. Okay, now the worst one. This is a monster. Okay, now even though this is in brackets, this is really just starting off with dividing or a fraction. So we're going to break this apart into two different logs. So the log of the numerator. And since you don't see it, you understand it's a base 10. So it's the log of the numerator. So the numerator is 100x to the 5th cube root of 8 minus x all over, right? So they're going to subtract that from another log, and again base 10 because you don't see it, default is base 10, of 3 times x plus 9 squared. Okay, so let's simplify. So the first one is log Now, we have 100 times x to the 5th times a cube root of 8 minus x. So there's 3 different factors here, right? There's multiplication there, and there's multiplication here, and here, right? So well, technically that's not a multiplication. There we go. Okay. So we have 100 times x to the 5th times cube root of 8 minus x. Okay, so we end up with log of 100 plus log of x to the 5th plus log of cube root. I'm just going to rewrite this as 8 minus x. But instead of a cube root, that index is going to be the denominator, 1 to the 3rd. Just skip a little step there. Next, we're going to subtract the denominator, this whole thing right here, which is log 3 multiplied by x plus 9 to the 2nd power. I'm going to break that apart into 2 different ones. So put that in parentheses for a little bit. I end up with log of 3 plus log parenthesis x plus 9 to the 2nd in parentheses. Okay, so let's simplify this. Log of 100. Now you have to remember that the log is really base 10 when you don't see it. So this is really 10 to what power is 100? Well, it's 2. So this whole entire thing is going to go to 2. So that just turns into a 2. Next one is plus log x to the 5th power. We're simply going to pull that 5 to the front. And then we need to plus 5 log x. Next, we're going to bring this 1/3 power to the front. So we end up with plus 1/3 log 8 minus x. Okay, next we're going to kind of distribute this, implied or negative 1 there. So we're just going to flip all the signs there. So these both become negative. So we end up with minus log 3 minus, now we're going to bring this 2 right here to the front. We end up with 2 log x plus 9. And it doesn't look like anything's going to really simplify on this second part. Something like that. Okay. And that's it.